Hello, everyone, and welcome to our Spain Data Community Meetup Best Practices in Data. My name is Katerina, and I have the honor of moderating this meetup today. So, we gathered together to dive into two most essential components of working with data: master data management and databases. But before we start, I'd like to highlight that this meetup is organized by Spain Data Community and is powered by EPAM. And today at this meetup, we have a special guest, Evgen Birzhenko, yeah, head of EPAM Spain. So Evgen, the floor is yours. This is for you.
Thank you. Let's check if it works.
Just a second. Evgen.
Uh-huh. Oh, wow. Let me. All right. That's great. Nope. Oh, yes. Oh, yes, it does. Hey, guys. So we're EPAM Systems. And if there's anything you ever wanted to ask about us, but we're afraid of, I'm going to tell you that all of that right away. We are a digital software engineering company. We've been doing quite a lot of cool stuff for many IT, but also non-IT companies all over the world in more than 30 years of our experience. Uh, we've been nominated by several very highly respectable sources for the work we did, for our work culture, for our learning culture, for our engineering excellence, for other achievements. And we're present in pretty much, good 5 dozens plus of countries all across the world. And I don't like saying, we have 57,450 plus EPAM researchers. So I would like to say we're nearing to be 60,000 of really talented individuals, technical, non-technical, software developers, engineers, data engineers among them, who are really daily trying to do their best in everything they do, in every job they undertake, and at the same time, try to develop the technical competencies, try to contribute to the society. And as an outcome, we are running those meetups to share some of the things we've learned in that experience with you, and give you a chance to appreciate some of it, to maybe try some of those things that you learn in your own professional experience. About EPAM Spain, just a few words. So we are by design the most international delivery location that EPAM has, officially confirmed by independent sources, verified. We've got more than 1,500 EPAM Spain colleagues who are working with us from several locations all over the country, although we have only 2 physical offices at the moment. Worth noting, one is in Malaga, another is in Madrid. We are fairly diverse, we are fairly interesting as we are, and as EPAM Spain, we are quite young. We're only 5 years old, but we've already gotten some of the recognition for being one of the best companies in Spain for professional development, for learning. Again, that's a reference to our learning culture. Well, the fact that we are international, the fact that we work with talent from all over the world and with some of the customers who are the top of the world in their respective categories, be it financial services or be it healthcare, travel and hospitality, etc., etc. Uh, Last but not least, we've been recognized by Glassdoor as well as some of the top places to work. Well, this year, hopefully, will be carried over to next year's. So just in case, if you were wondering, how to land yourself a job with EPAM, in case if you're joining us, from another company, yeah, just feel free to ask. We're always too happy to answer that. With that, I think my assigned part is coming to an end. If you guys have any questions, if there's anything you're interested in, if we can expand on any topics that we're covering in this meetup, just let us know. We're always open to answer your questions.
Thanks so much, Evgen. Okay, great.
Thanks, Kate.
Yeah. Thank you so much. And Also, I'm thrilled to introduce our Spain data community leader, Sergey Stafeev. Sergey, please, the floor is yours.
And first of all, I would like to say thank you. Thank you for everyone who joined. I would like to give a warm welcome to our new community members. And also a special thanks to our speakers and community team for the great work. What our community is. Actually, it's a group, and I guess it's a pretty large group of people who are who is interested in everything about data, be it data software engineering, be it data science, data quality, machine learning, AI, architecture, management, and so on. And of course, it's our expertise, and we would like to share our expertise with our community members as well. Actually, during the lifetime of our community, we've organized a lot of events in both formats, external and internal, and we are growing really fast. As well, our location is growing not only in terms of EPAM headcount, but also globally. And I guess our focus for the next maybe year or for the next future will be to focus on collaboration, to invite more and more participants in our community, especially external ones, and to work on different kind of collaborative events. And I would encourage you to subscribe to join our community. I guess you may know this link. It's our community portal. And also I would specifically highlight this delivery list. Please use it to share your ideas, to share your feedback, to ask how to become a speaker, because again, we are focused on collaboration, and feel free to ask us about any community events and provide your ideas. Thank you everyone, and have a good evening together with our data experts, Ahmad and Alexey. Thank you.
We are ready to start our technical parts. So I would like to introduce our first speaker, Ahmad Hawrani. Ahmad will share his experience with different databases, their strengths and weaknesses. So he will share his insights with you.
Hello everyone. My name is Ahmad Hawrani. I'm the head of data DevOps unit here in Malaga, Spain, EPAM. Today we will be discussing a rather interesting topic. It would be how to choose your database. There is always a need for growing your databases, and the business needs do change from time to time, and we do come to a point in a lifetime of the software where do we need to change our database system. However, before we actually start and moving forward with the database migration, because on production, it's a very costly process, I would like you to consider these points before making such a decision. The database engines are often highly tunable. You can update the garbage collection. You can update the CPU or memory. Compaction strategy is another way to go. In order to do that, I would advise you to read the manual of the database. Each database model comes with its documentation, and I would advise to read the manual back to back twice. There you would be looking for configs, for tweaks in your database. Such tweaks could be what we discussed earlier, such as the memory utilization, the compaction strategy. If those have come to an end and you actually gone through this, yet you still need more of your database, current database engine, I would advise to consider adding a caching layer in front of your database engine. If you've already done that, maybe you can consider sharding or even read replicas. If you have a lot of reads coming in more than writes to serving your data needs, a read replica can come into play. If you've already done that and you still need help out of your system, I would advise to reach out to experts. You can find experts offline or online communities that would help a lot. We have come to the conclusion that we do actually need a new database engine. We as software engineers are often attracted to what's new and shiny. However, in database systems, this is not often the case. The more boring it is, the older the model has been out in the market, the better it is for actual real business cases. Why, you might ask, why is it better? If the database engine has been out in the market for years, it is way more mature than a newer one that was released a few months ago or a year ago. And you will find wider adaptation for it in the community, more use cases for such a database model. And it has a higher compatibility with the rest of your ecosystem. Predictability, you know what load it might serve with the current hardware you have. And there are proven solutions for such a use case in this database model you have. There are multiple database models out there in the market. I would go over all of them today. We start with relational. That's what we're most familiar with, probably. It is like Microsoft SQL, MySQL, Postgres. Another one is GraphDB. An example for that would be Neo4j or GraphQL. Another one is Cassandra. That's a wide column database or multi-dimensional key value. A key value itself, that's in-memory database. That's when the data is stored mostly in memory, since the memory is fast. And time series, that's when you care most. The most important aspect of your data is the time. And last but not least, the document database. MongoDB is a famous example, and AWS Document DB. Whenever we talk about databases, we often come across CAP theorem. CAP theorem is a theory that was set, I think, in the early 70s, that it tells you that you can always guarantee 2 out of 3 guarantees. That is consistency, availability, and partition tolerance. By consistency, I mean that the data is consistent. Whenever you query it, you always get the most recent right, the most recent right. Availability, it's guaranteed that you always get a response, not necessarily the latest. By that, I mean if the query were to come a few seconds or a few minutes later, you would get a different response from what was initially received. Partition tolerance. The system will tolerate partition loss. If there is a network issue in the system, you're still guaranteed to get a response from the system. An example for CA, you can always get 2 out of 3. So that would be MySQL, Postgres, or Microsoft SQL. CP, that would be Apache HBase or MongoDB. And to guarantee availability and partition tolerance, that's when you have Amazon DynamoDB or Cassandra. And depending on how you configure it, you might get different responses. Next slide would be relational databases. This is what we're most used to, most common one that currently represents 72% of the market. Most companies use it. We started learning it. It's best for interconnected data. When you have your data diagrams like that, that's interconnected data. It does support ACID, transactional support, and it's best known for consistency and reliability. It's not made for scalability requirements. I must say it does support scalability, but comes at the cost of hardware. So if you have a database like this is fine. If it grows from this to this, you have a problem. If it keeps growing, you have yet a bigger problem. That's when you probably need to move to a different database model. The next most common one is key value database. I think the bigger question behind it is, since the RAM is so fast, why not load all the data in RAM and retrieve it from there? That's when we have key value databases. Another name for it is an in-memory database. It's just for unstructured data. It's flexible with the data you put. Stored in memory, as the name says. It's super fast because it's in memory again. And however, for mission critical apps, we do need to store the data on the hard drive because we don't want to lose it. If the power goes out of the system or failure happens, we don't want to lose the data for mission critical apps. For that, we do store it in one of two ways. It's point-in-time snapshots or append-only files. Point-in-time snapshots take a copy of what you have in memory and stores it on the hard drive. Append-only files, whenever you have a new data coming in, you store it into the hard drive. And it's really good for data retrieval. It serves a lot of reads really well. It's not made for complex data structures. It's not made for ACID transactions. However, some systems do support ACID transactions in memory database, but that comes with trade-offs. And it's not made for historical data retrieval. You cannot expect to have terabytes of data stored in memory and you retrieve it for the past 15 years. You might need a different model for that. A real life example for this would be Twitter. It uses Redis to cache its tweet. Yeah, basically when someone tweets, the data goes into, or the tweet itself goes into the memory and retrieves back again to your timeline. It's super powered or it's ultra fast, super fast. Wide column database. That's also known as multidimensional database, a key value store, or the previous one we described but in steroids. So since the data object we have, it correlates to itself, why not store it at the same level? So whenever we retrieve it, we retrieve its correlated data with it, or its metadata with it. You can query it by primary key or partition key. It's highly partitionable. You can have copies of your data among different nodes, and it will be served. This is best for denormalized data, meaning that the correlated data is not copied across the cluster. And it's very well for write optimized operations. It's not made for random filtering. You cannot filter it by a key that was not set before. So if you have only your primary key and your partition key, and then you want to query it by timestamp, that's not doable in wide column databases. Also not made for ACID transactions and not for rich queries, which we have discussed just now. A famous example for this would be Spotify. They use it to store the metadata about playlists and songs. And if you do think about it, it makes sense because to retrieve data about a song, you might look for the singer or the album or a combined of those both. Then you would have it. And it's highly scalable. Next one, a famous MongoDB, and it's the best friend. Basically, you a JSON file, you store it in the data engine, and you retrieve it by the keys you already have. It's best known for denormalized data, flexible schema, and indexing and rich queries. If you have proper indexing on your document DB, usually that's the most often caveat, how to properly set the right index for your data in order to retrieve it faster. It's not made for complex relationships and joins. And referential integrity. What do I mean by that? When you have a document that's gets updated by two parents, if it was retrieved from one parent, it doesn't necessarily mean you will get the latest data. And it's not made for rich queries. It has a superpower of being the most intuitive. A real life example by that would be New York Times. They use DocumentDB to store documents, news, and their correlated news that relates to it because it has a power of storing complex data structure. The next common one, this one is less common than the rest, is graph databases. You use it when you value the relationship between the data more than the data itself. So this one came into most usage with the rise of social media events or social media platforms. That's when you have the relationship between one person and another, and the relationship is what you want to get without calculating at runtime. You get the data at runtime, but the relationship's already been defined before. It's best for densely connected data, complex data structures, and multi-hop relationships. I mean, of course, this is a small example, but it can expand into much wider platforms. Not for it's hard to scale once you put your relationships at the start of your cluster. You have it. If you want to scale, of course, it's scalable, but not as easy as white column databases. There, you just throw in a new node, and it will adapt into the cluster. Not made for heavy write workloads or historical data retrieval. The use case for this is the relationship more than the data itself. A real life example by this is probably something we've all used. The people you may know on LinkedIn, that's um, that's a feature that gets served from graph database. Next one, time series database. That's when the time of your data is the most important factor of your data, or you want to look for trends in your data. If you're comparing historical data with current data and looking for projections in your data, an example for this would be um, New Relic. New Relic, that's an APM, application performance monitoring tool. It monitors your application and stores its previous state, its current state, and if there is an outliner in your data, it will detect it for you. So it's best known for data with known limited lifespan, high volume write workloads, and anomaly detection. Quite often in these models, the anomaly detection comes by default from the database system itself. You don't have to write any code for it. It's out there for you. Not made for complex relationships and joins, not made for flexible schema, or it cannot be treated as a general purpose or multi-purpose database model. The primary use case for it is that the database, the temporal efficiency, basically I want to compare the current state to the previous state or project for a new state of the system. Time series database comes into play. Okay, we've taken those decisions and we are at the state of choosing a new database model for us. What can go wrong? This is the most single important decision probably to make in a system. It can affect multiple factors. If you do choose the wrong model for that use case, it can affect performance. You're not going to be able to adapt to the business needs. You might have high CPU on one of your clusters, and that will make scalability also a problem. if you're not able to scale up to demand, or in order to scale, you have to create a new cluster and copy your data all over again, that might take weeks or months, depending on the use case. Increased cost. We just kind of described that. If you need to copy the data in order to up with demand, that's a lot of new hardware. Data loss or corruption. If all of these combined and you're still unable to keep up with demand, you might have data loss or data corruption because something was copied, but the delta was not copied as much. Delta by delta, I mean that data that was not copied since the start. Data silos, you might end up with that. A lot of companies often come to this because of what we described earlier. A data silo is when you need your data for a new business need, but you cannot copy it, you cannot scale it. So you copy it offline and you bring it into a new system, and that system has a copy of the data that was in a different database model. So you have two copies of your data, and that's not good. All of these combined can lead to an impaired decision making. If you have the wrong data and the new system is reading from it and it's not acting as you expect, you would have the wrong, yeah, you would have an impaired decision making. Regulatory compliance. If the system needs data to be out there for, let's say, past 15 years, to be presented and queryable, live data, and you have the wrong database model for it, you might end up with a regulatory compliance. An example for that, imagine a bank that has financial data, but does not have anything older than 5 years. That's a problem. I would like to say this, that navigating through trade-offs, especially in software engineering at scale, especially for databases, this is an essential part of software engineering. Yeah, that took me a while to come up with. A real world example with this is a global e-commerce company that came to us. They had a problem with their monolithic data architecture. It became heavy, a lot of writes, and a lot of mismanaged reads, a lot of mismanaged volumes of data, dealing with a lot of data silos, and maintaining it, it became a problem for this. They needed a solution out of this. What we proposed was a data mesh architecture. That means that we move away from the centralized data system they have into a more governed data, decentralized governed data model, where individual domain served by a different team. Each team is responsible for their data and gets into a decentralized data model, or yeah. What we started with is assessment, reviewing the existing architecture, reviewing their data needs, the most important data data sets they have, and we mapped the dependencies. We started by doing we designed the data mesh architecture, set data product responsibilities and governing policies. The migration started with a phased migration. First, we took the most important data sets, migrated it into the new system, and for that we used Apache NiFi and Apache Beam for the movement. The governance that was done using Colibra, and the outcome was a flexible, scalable, resilient data mesh that serves a lot of purposes. conclusion out of this. There is no one-size-fits-all database model for all of your use cases. Quite often in an ecosystem, you would have multiple data systems or data models that serve different needs. A combination of those is often the best solution you can come up with. Thank you for your time and listening. If you have any questions, feel free to ask. No one?
Any questions from the audience?
No? Okay.
How does it work? This way. I just thought so, Ahmad, when you were going through your slides with different database types, you went through the key value and then white column, and it really looks like white column is a kind of key value on steroids or something. I don't remember how you formulated that, but I just wonder, so what could be the reason of choosing white column database? I remember we had one in one of the projects in the past, but it was legacy, and it was like, well, we didn't touch it. It kind of the data access layer already worked, so I didn't think a lot about why was this choice taken sometime before us. So what do you think about that?
I
Once
must
again,
say that value in steroids is an oversimplification of the.
maybe you said it in a different way, right?
Yeah. I said it this way, but it's an oversimplification. Some people describe it as a huge hash map, the white column database. I mean, in comparison, the in-memory database, you usually have one key related to one value, and you retrieve the value. In white column, you have one key, one partition key, and multiple values. That's why there was a comparison between them.
Right. So I just wonder, what kind of data should I have to use, let's say, Cassandra? So what's special in that?
When you need to partition your data a lot and you have a lot of writes to it, yeah, when you have a lot of writes to your system, a simple Redis will not be able to handle your traffic. Cassandra is a way out of this, I think.
So it's like, well, I just wonder, we also could have the SQL-based massive parallel processing systems, right? Like Redshift, for example,
Yeah.
when you can have or Teradata, there are others, BigQuery. So you may have a very, very distributed, like, well, regular type of table.
Yes.
So I just
To
wonder
carry
what.
the same amount of data that Redshift might have into Cassandra, I think with Cassandra we'd use less hardware than just Redshift. I mean, Redshift is of course only for AWS.
Yeah, definitely. And it's its turn.
And
In
the
its
cost
turn, it's
here-
Postgres on steroids, because
Yeah.
Redshift is kind of modified Postgres.
But it's a different use case. The price does play a factor in this comparison, but let's say that it wasn't a factor. I think the use case for Cassandra versus Redshift would be the amount of writes and partition tolerance you would have. I don't think Redshift would serve as much as partition tolerance you would have in Cassandra.
Does also Cassandra manage better sparse data?
Sparse data, of course.
Does it? So I just wonder, what's that special in this? Or what's so special in management of sparse data by Cassandra?
For example, you got new type of the transactions. Does it work at all?
Yeah, it does work.
No idea. Really.
You got new type of the transaction, and for Redshift, for example, table, you have to add new column for such kind of data.
Yep.
But for Cassandra, you can just write this data and not care about.
But what do you mean by writing data? Because I think it also has columns, Cassandra. Where it doesn't get rid of the notion of column.
I think in Cassandra and in my experience, DynamoDB, if you already defined your primary key and your partition key, the rest really does not matter. You can add it or not add it. It will be added to the table. But for Redshift, you have to update the metadata for that. I think.
It's really interesting. It's just that I don't have the answer out of my pocket. This is something that where I myself sometimes it gives me hard time to understand this specific case of introducing Cassandra, Google Bigtable, or others. I remember I also heard about lots of writes. I think it would be interesting to elaborate on this topic if this whole wide column databases are still actual, because I don't see them, well, a lot of people using that the last time. Happens rarely. But it would be interesting to talk about that next time, maybe.
Thank you. Any other questions from the audience?
Okay, thank you for your questions. Actually, we had some comments from chat. Tatiana said, great presentation. Thank you, Ahmad.
Thank you.
And Stanislav actually said great presentation as well, and asked you how to set up a multi-DB approach.
Multi-DB approach. That's a data mesh we discussed earlier, depending on the use case of the data. So if it's transactional, you would store it in a transactional model. If it's NoSQL, you would choose a NoSQL model for that. A DynamoDB, what we just discussed, can also serve it. Data governance is what governs this approach and authorizates, that's the wrong word, allows people to, or teams based on their need and privileges to access such a model or not.
Okay, thank you.
How does data mesh look like? I didn't participate in data mesh projects. So does it just mean we have many databases? Because yeah, I participated in such, and it was never called data mesh. Does it mean that there is some structural pattern, like for example, in microservices, there are things like types like registry. You kind of have some microservice that may watch other microservices or be a front end to some group of microservices. But what is about data mesh?
I must say it's a new term. It came into existence, I think, 3 years ago. Before that, it was a data lake. However, if you want to expand the data lake and make it available for more data needs and data solutions, you'd have your Spark data stored somewhere, and your data coming from logs, you have it stored in storage. Combining these together and governing all of them using one data model, that's a definition of data mesh. However, it is different from one use case to another. So it depends on the use case, really.
Yeah, so what I was thinking is, in order to build data mesh, what do you need? Is it just that, again, it's a system, it's a very, is data mesh equals to just highly heterogeneous system with various databases different for different use case? Or you have something like, I don't know, database registry, some front ends, or whatever kind of, well, infrastructural entities that govern databases or whatever.
I think what really differentiates data mesh from a data warehouse or data lake is the governance of data, is the governance, yeah, of the data and liability of teams. So each team will be able to contribute to the data mesh and or read from it, depends if they're allowed or not. In the previous data warehousing or data lake approach, the data governance was not as precisely described as in data mesh.
So data mesh for us is a kind of well-governed data lake.
I would say so, yeah.
Got it.
Thank you. And we had one more comment, I guess, on your community platform. Again, Marlon said, "Thank you, Ahmad.
Yeah, thank you.
Congratulations, good presentation."
Thank you.
Okay, so Ahmad, thank you so much for your excellent presentation.
Thank you.
If there are no more questions, we are going to have 10 minutes break, coffee break, and we're waiting for you here in 10 minutes.
Где пульт? Пульт где?
Great. And I have the pleasure of introducing our second speaker. Our second speaker is Alexey Kurinov. So Alexey will share his real life case implementing master data. Alexey, the floor is yours. Welcome.
Good evening, guys. So first of all, thank you to Ahmad for interesting lecture about choosing database, and you are all ready to challenge me with tricky questions about that. Just don't ask me about Cassandra. So first couple of words about me. I'm for more than 20 years in software development. I have experience in pretty wide tech stack. It's web development, front end and back end. It's desktop applications, it's cross operating hybrid applications, even mobile applications. It's, of course, it's cloud-based solution. And recent 4 years, I've been working in EPAM in data practice and focusing on data platforms, data solutions. And today we are going to talk about massive data management system, and we'll take a look at real case of usage of master data in one of our client solutions, and what problems they face there, and why they want to replace the solution with something else, and what we propose to them. First of all, we will talk about theory, about master data in general, and then take a look at particular case. And in second part of the presentation, we will take a look at some technical details of implementation of our POC. All right. So what's master data? It's actually, I believe you already saw this in your projects, and most common definition of master data is a data that provides the context for your business operation, for your transactional operations in the system, and how to distinguish what's master data and what's not. So if you imagine that you have, for example, we'll take a look at very simple case, like an internet store, right? And how you can describe what happens there. So basically, customers buy products there. And in this sentence, nouns are master data. So it's how you can very simple to catch the master data and separate it from the transactional data. In our case, customers and products and goods on this diagram are master data. And your software, your system, your process generates the transactions, which are orders in our cases, and orders are transactional data, and everything around that is a business context. Without this context, without this data, orders never been generated, never can be generated. And you can see that you have a lot of different data around it. And basically, master data by its nature, it's non-transactional data. And you can see different colors on diagram. So some of these data are specific. It's called reference data. It refers to really slow change dimensions like context, locations, etc. You probably call it lookups in your system. So some lookups data, right? So, and yeah, we can call it like a special data, but it's still master data. All right, and to deal with master data, we use master data management system. So the entire goal of the master data management is to provide a single source of accurate and valid data for different components of your data platform. So you have a lot of multiple departments in your company, in our internet shop, for example. So it's shipping, sales, etc. And every department has its own software, and this software should have access to same data. So all our departments should should have deal with Coca-Cola, and this Coca-Cola have the same color for all departments. And we can do it with our master data management system. So, of course, core of any master data management system is data processing. Ingest data from external data sources, maybe from internal data sources. It transforms and normalizes data to your company standards, to your company formats. It guarantees data qualities according to the data qualities rules in your company. On top of the core processing, master data management system might have different options and different components which gives you additional capabilities. For example, it's data catalog. It's also depending on particular use cases, it can provide you different features like searching for data, searching for metadata, analyzing data lineage, business data lineage, or technical data lineage, depending on use cases. It allows our consumers of our master data, for example, our finances department, they can see when the master data comes from, with the data sources, who is responsible for supporting this kind of metadata or master data. And this way, our consumers can trust our data. They can make sure that data is valid, that data is processed by our data stewards department. Data security is a really important part of any master data management system. So, and it's of course, it provides the authorization, different levels of authorization, and compliance with PCI, for example, right? But actually, master data usually doesn't deal with sensitive data, but sometimes it can, and we are ready to this. So let's go ahead and take a look at some particular case. So one of EPAM's customers has a data platform, but big data platform, and as part of this data platform, we have a master data management system. This diagram represents the architecture. I will explain why we take a look at this so deeply, but your first impression should be, wow, it's complex, it's overcomplicated. Yes, that's it. So I tried to split it to different layers. So ingestion layer, where's my ingestion layer, data preparation layer, and data publishing layer. On the right side, you can see our consumers, and orange arrows represent the data which already processed, prepared for consumptions. What's interesting, we can see that these orange arrows can across all our layers, including ingestion, preparation, publishing. Sometimes it starts with from data preparation, sometimes from publishing layer. We have here 3 solutions from market which can help you to manage master data. It's Talent. You can find it on market. It's SAP system and Zenodo data virtualization. It's not about master data. It's just data virtualization which helps us to publish data. And we have multiple storage. We have master data which located in multiple storage, right? So we have a lot of jobs which moves data from one storage to another. And again, we have 2 platforms which integrated via primary database. Actually, these databases are the same. Here we have a matrix of capability of the system and how these capabilities are presented in different components of the system. So talent obviously represents some capability, and SAP as well. So some of them, which are marked with this gray color, I guess, it's available but it's not used. Another color represents the capability which used our system, and you can see that some capabilities from different solutions are used in the system. So we have duplicated functionality from different systems. Sometimes we have data quality rules, for example, which are implemented to multiple companies. Just noted. And this is an example of SAP pipeline, how it looks like, how your real life of developers looks like. So every day they need to support this pipeline. It's just one of the hundreds pipelines there. So it's low code system, which looks good on presentations, but in your real life, you have to deal with this spaghetti code. And believe me, it's really tricky to support this. And because of this specific, we have a lot of additional temporary tables, which increases the amount of data to handle, and it's obviously increases requirements to storage. And let's take a look what we have in summary of reviewing this particular case. So our clients wants to replace this solution with something else. And of course, main driver is not the low-code system. It's not the multiple storages at all, because the main driver is money. And next year, the license on Talent components is expired, and moreover, this version of Talent supporting is going to be stopped, and no choice, we have to replace it. And this is a good chance, this is a good time to think about other disadvantages, other problems with the solution. So just to remind you, we have problems with supportability of these complex pipelines. We have a lot of duplicated code. We have multiple tools. We don't have CI/CD, so etc., etc., etc. Data quality is provided by the solution, but again, data quality rules are duplicated over all pipelines. You don't have a unifying tool to manage these rules in some single UI, for example, right? Data publishing problems is also something we need to fix. So because a lot of pipelines which are run by scheduler, we have to synchronize the scheduled pipelines to minimize the timeliness of data, right? So there are some minor issues like performance of Talent REST API and Denoda, which is really a good tool, but probably it's the extra layer in the system because it's kind of consumer of our master data management system, the single consumer, because other consumers use Denoda. But just because of Denoda limitations, which we can't implement very interesting feature like event streaming of our data master data changes. So our consumers can subscribe to changes of our master data, and sometimes, really often, they need it. All right. So EPAM was asked to implement some POC to check if we can implement some custom solution. Of course, we can investigate the market to find the ready master data, the solid solution. But I guess it's really expensive, and for our particular case, we don't have a lot of data. So we probably have some 50 entities in our system. We don't have large amount of master data. And the goal is to compare prices of buy solution versus build solution. So, and we asked to build a custom solution to some prototype, just to check our ideas, to check our technical ideas into our architecture, and to estimate potential cost of the system, including operational costs, of course, and we implemented this POC. All right, so the second part of our presentation is about the implementation of our POC. You will see some technical details, but we start with scope and concepts. Scope of POC is really limited. We are not going to implement a lot of capabilities of master data, like data catalog, security, etc. We were focusing on implementing of core processing of data, so ingestion, data preparation, and publishing. And what? All right, okay. So just false alarm to wake up. Okay, this blue scope is the scope of our POC. We are going to start with data modeling, ingestion data, processing, and publication. All other capabilities of potential capabilities of master data management is out of scope of POC. And first of all, we want to organize data flows. In the current solution, we saw that our master data can be, so we have several multiple inputs to master data and multiple outputs. The data stewards were able to edit master data right in primary database, and it's risky from the perspective of data quality. That's why we try to build a data flow like a single stream, right? So we have a single input. Master data is primary data which published, and in the center we have a kind of circle which allows stewardship staff to fix data if it's really needed to do it manually, and our core pipeline just process the data. I will explain all details of this pipeline on the next slide, but right now we need to understand the single stream and single input for primary data and single output. So the entire idea, the main idea of the pipeline is we wanted to implement the single pipeline, which can process any kind of data. And of course, we have multiple entities of data. We have cities, airports. By the way, I will use some travel domain terms because our client is in travel domain. So we will deal with airports, cities, hotels, etc., etc. And to process different types of data with single pipeline, we also suggest some kind of low code approach. So we wanted to check the ideas of implementation configuration. Instead of Visual Tool, we use JSON files here, and these JSON files are applied to the single pipeline. And again, we have an ingestion layer, then our staging layer processes data. It's only the single pipeline here in the core of the system, which includes different stages, but all of these stages are configured by external configuration. This is what we want to change during the lifetime of our system. And this pipeline is stable, right? So after data is processed, it goes to staging database. Stewards are able to fix problems in data manually if it's needed, and then publish to primary database. And data consumers takes data from primary database. So that's the idea. Let's take a look how it's implemented. I guess you are interested in how it was implemented, and we based it on AWS solutions. It's really simple, of course. we use lambdas for ingestion. Lambdas reads configuration for ingestion layer. So every model has set of configurations file for ingestion and processing. So lambdas ingest data from external data sources. And then the main pipeline is also lambda-based solution, process data and push to StageDB. Data stewards are able to work with data via web application. It's again really simple lambda-based REST API and some React applications. Very simple. By the way, we have two types of ingestion. So it's standard batch ingestions, ingestion from external databases, REST APIs, and files. And we have pretty interesting case of real-time ingestion. It's not streamed, so it's real-time, but it's not streamed. It's an API which is exposed to our consumers, and consumers can request data via this API. And if data is not found, this data is inserted to the database. So it's at the same time, it's this consumer and producer. So client of this API, producer and consumer at the same time. And this real-time ingestion is a strict performance requirements, so we need to handle this request in 300 milliseconds. It's tricky because pretty complex. Yeah, because pretty complex algorithm inside of this. We will take a look later. All right. So again, so configuration is really important because we implement the core pipeline, and then configuration is the what is really defines the behavior, really defines how data is processed. So and this pipeline, we need to address some issues which we have in current solutions. First of all, in deduplication of code. So we don't want to implement the same rules for every entity every time we take a look at this. So for example, we don't want to implement country name check for countries, airports, and cities because we have country names in every of these entities, right? And we would like to reuse the same rules for different entities. And we take it in mind. All right, so this is how JSON files looks like. So it's video, by the way, so it's going to be changed. I'll try to change this video. So for validation, we use ready solutions, JSON validation schema, JSON schema library. And this is format of JSON which is designed for JSON schema. It's not our design. We just reuse the existing solution. And we did not implement validation code. We just need to implement the validation code. And this is how we can you pause the video? Okay. All right. So remember, I told you about the reusable of configuration. We use reference to files. For example, country code file represents the validation rules for country code. Or in this case, it's not validation, it's about other stage. But anyway, so we have the same approach for all configuration files. We can, for country code in the cities JSON, we can refer it to as a separate JSON file. So country code JSON can be used in multiple files. For in this particular case, it's city. The same for location name. And this way we can reuse the configuration. All right. Let's go ahead. And for every stage of the data processing, we have a set of configurations file for every entity. We take a look at example of every configuration file later. So data ingestion is separated from core data processing because of different reasons. First of all, security, because it is obviously to care about security and ingestion because it has access to external data sources, and some data producers which push files to our system also have some its own configurations security settings, right? So and again, we would like to have a raw data storage just to able to reprocess incoming data when anytime we want. So that's why data ingestion is completely separated from other part of the system. And staging layer it starts with data transformation. So it's the first stage of our core pipeline. And again, first of all, we need to map the external data model to our internal data model. It's pretty simple. So we have a configuration file which converts city name to name, and for example, location to location name. So this way we can map external model to our internal. If we would like to see some new fields in our system and we don't have this field in external database, it's also doable. Okay, no problem. And this is how input model converts to our internal model. Pretty simple. Data synthesization is the next stage, and it's about formatting data. So we would like to have the unified formats of all data for all our departments, for our consumers. So we would like to, for example, make some strings uppercase to format data and Boolean values, etc., etc. And we have another configuration files which just defines the formatting rules, for example, right? Data enrichment. So another interesting story, because sometimes we need to enrich our entities with something else. For example, we would like to see weather in our cities, right? So we pull data, pull city data from one data source, and pull weather from another, and enrich cities data with weather. But actually, the most common case in this particular project is just linking existing entities in the system, because incoming data, for example, hotel, usually has description of country like a string, like United States, for example. But we have normal form, we have relational database, we have normal form, and we have countries reference data lookup in our system. And we don't just publish country names from external source because we don't trust this external data source. And we trust all data we processed already. And we have our own countries lookup. And this is why we replace this country with our country ID. Because this country ID refers to valid data, to accurate data we already have in our system. And this is what we call enrichment, right? So we just replace strings with our IDs. So we link entities, we link data. All right. So data validation is probably what's our consumers is really interested in. So they understand how it works. So for all previous stages, it doesn't make sense for consumers, but data validation is really important for them. So they would like to define data quality rules. They would like to have ability to edit them. And of course, our JSON files is not a perfect way to support data validation rules from perspective of business guys, right? But again, this is POC. It has a limited functionality, but it allows us to configure data validation rules. And as I already mentioned, we choose JSON schema validation engine, and just to use the approach. So we did not invite real, and it actually saves us a lot of time. And JSON schema provides us a lot of interesting feature like conditional rules right? So it allows us to use regex, it allows us to use required properties, etc. A lot of interesting things. All right, so data matching stage. This is where data management system, master data management system, may be different from ETL, which you probably think we put in the simple ETL before, right? But data matching is a kill feature of our system. So killer feature. Sometimes, actually, every minute we pull in data from external data sources. For example, hotels is a really good example of why we need data matching, why we need data duplication. So because really often we get hotels rows, hotel records, which are really similar each other. We have typo in names. We have different fonts, but for the same hotels. And of course, we do not to have a duplicated data in our system. So we need to find similar hotels and merge them to the single one. Right? So good example. So you have 3 different cards for the same hotel, and we need to deduplicate it. How we implement this? So we choose, by the way, Postgres just because it's time to talk about choosing database. First of all, we prefer using relational database because master data match normal form really well, and foreign keys allows us to control consistency of data, right? Yeah, of course, it's really good match to relational and to relative data model. And when we choosing the concrete some certain database, we choose Postgres because it has a trigram indexes, trigram model, and this is inbuilt feature of Postgres, which allows us to calculate similarity between 2 records. Right? So, and to get some measurable value of distance between 2 records, right on the database, we just run SQL query, we got the distance between rows. We do not want to implement another algorithm on Java, Python, or whatever, just to calculate the similarity. Right? So we have right now. So we have input data, put it to database, and then run SQL query and get the values for every record, how they similar to each other, right? So, and our configuration file allows us to configure this this process. By the way, we just example for total for name we have configuration. Fuzzy means that we are going to use trigram index. For country code, we just compare it as is without using trigram index, right? And we have some threshold. We calculated every property has its own weight to which consider it in the final formula, final value, and we have some threshold for which defines if it's similar records or not. Right? So after every records in the ingested data in processed data is marked with particular values of similarity, we can mark them as unique data or probably data which can be reviewed, should be reviewed by stewards, and stewards will decide if it's unique data or maybe not. It can be automated based on threshold, of course. So it depends on particular business case. So what we have in results? First of all, it's money, right? So we estimated the operational cost of this system, and it's about some 1,000 kilo per month operational cost. And by the way, it's a little bit overestimated because I use some extra. So for estimation, I increase the amount of data a little bit just to have some buffer, right? And I force the stewards to click UI really, really fast just to be ready for high load system, right? So we address data quality issue. So right now we have the data quality rules in our configurations file. They are not duplicated. And if we implement some UI tool to manage these files, we'll have a single place where we can set up these data quality rules. And again, these data quality rules are applied to data before it's published to primary database. It's our core pipeline checks the data quality rules, run it against data, and invalid data just can be pushed to primary database. So supportability, of course, it's Python, it's Lambda. We have a pretty standard life cycle for software development. We have only one pipeline. We have CI/CD, we have unit tests, we have states, all available tools for code source code analysis. So instead of having this spaghetti in our current solution. So performance. Cloud serverless allows us to be scalable, right? So you can, if you're afraid that your Lambda runtimes is not enough, you can replace it with ECS task or whatever. You can probably another way is cut your files to smaller chunks to be fit into runtime of Lambda, no problem. So we're scalable by nature. And for real-time service, so this is a duplication algorithm, actually takes time in current solution. But when we move to Postgres, we use the powerful of database, right? And by the way, we tested it on Aurora. We choose Aurora cluster, and we set up a 3-node cluster, not really top level nodes, just for the 2x large, I guess. So not so expensive. And with this approach, we run performance tests, and you can see what it's about. We skip it. It's here. And this is our performance test of real time. So let me just remind the case. So consumers calls API with a single role, and he wants to get duplicated data back, right? So he push hotel data, and he wants to back the hotel, which is already validated and which already published to other consumers. Of course, we need to check similarity. We need to find the similar hotel. If it's similar, we need to replace in incoming data something else, which already validate. And you can see that requirements is 300 seconds. And by the way, most of our requests were processed 3 times faster, and the 995% is close to our requirements. So it's really impressive results. So just because they moved the deduplication algorithm to Postgres. And we have, by the way, I believe we have options to improve performance on Python side. We implement it on Python. And again, just to remind what we implemented our POC, we implemented only core processing pipeline. So if you want to extend your master data management system with something else, you have a lot of capabilities, a lot of functionality you would like to implement, depending on the demand of your customer. So we don't build the system for market, right? So we implement some custom solution for particular customer. And we are going to evolve this system step by step by adding some necessary functionality. It's going to be customer portal for self-service purposes. It's going to be BI reporting, data catalog, user manager, a lot of other features. But it's topic for future lecture. So, any questions, guys? Thank you for your attention. Go ahead.
I have two questions. The second one is a philosophical one.
Mhm.
The first one, thank you. The first one is about data quality. When we talking about MDM for the across the organization, for the
Mhm.
whole organization, we always faced with the data quality issues. For example, I also participated in the project where we tried to build some general system across the organization with golden records. And one of the example which I remember is the directions of sale points. Why it's a problem? Because in different regions we use different entities like region, city, zip code, etc. And even more interesting, they integrated Yacom solution, some Amazon-based selling points, online selling points. And here we operate not with the direction of the sell point, but the customer direction.
You are saying about different quality rules for different customers, right? No?
I'm saying that some data are not mergeable at all. Did you face with something like that?
Not mergeable with what?
With the similar data from another systems.
Ah.
For example, address the direction of the
Yeah.
of the
Okay, so good question. So, in our case, we also have multiple data sources for the same type of entity. For example, for hotels, we have different sources from Amadeus, it's some Sabre, of course. They have different models. They have some overlap data, so we have duplicated data in different structures, and we need to deal with it. All right, and what we can do with it, and we already started to a little bit change our POC solution. So, for example, mapping was extracted and moved from the core pipeline and stands between ingestion and core pipeline. So mapping is unique configuration, not the single configuration for this entity, but we split it to the different configurations. So mapping are specific for different data sources. After data is ingestion from data source, it's mapped by using some particular mapping configuration to the single data model, and then we already have the same data model, the unified data model, and all multiple data sources data are saved to the same data table in the same model, even if it's duplicated. Even we have some similar hotel names, for example, we can process it with our code. Yeah, but mapping is different in this case, of course. And again, we force our business analysts to fit the data flows to our new approach, right? Because right now it's spaghetti. So we have multiple input to the pipelines. We have multiple data storages, right? And we need to synchronize them somehow to move data to temporary tables. And that's why we have problems with merging data from different data sources. But if you have a single input, if you have a single pipe, right, we just need to change our mind, change our how we think about data flows in our systems. And if we can see the main stages. So we, generally speaking, we always have ingestion. We always need to map data to the some model. Right? We always need to format data, and we always need to apply data quality rules. So it's pretty standard ways, standard stages, right? Why we need to think about some other complex data flow? And the first step, it's not a technical step. It's more about how we think about data flow. So it's task for business analytics. Right? So that's why we work with them in cooperation, just to try to understand our approaches, just to try to build data flows in specification and documentation, and then apply this configuration to our unified pipeline. So it's not a technical problem, actually.
Yeah, that's not. Agree. Thank you. The second question is, as I already said, philosophical one. Just 1 month ago, I also participated in the decision making. What kind of interface for um, data quality rules to be provided to the users, and we also considered the option to use something like you share it, so some JSON or YAML files, and finally we decided to use the code itself because in reality, for example, the code which you share it on the screen, it does not translate typical language to the business language. It's just another way of writing the technical rules of the data quality, right? What is the benefits of using this JSON, do you see?
Again, it's about sources. We need to build a source solution. If you want to have a rich UI to build any possible quality rules you want, you can buy, I don't know, Talend again, new version of Talend. You will pay a couple of thousands, hundreds. I don't know. It's really expensive, right? For our particular cases, maybe it's easier to just implement JSON. And by the way, even with the current solution, when we have a data quality UI rules, so we can build data quality UI, when we need to change pipelines, when we need to onboard some new data source, we create task for developers, board developers.
No, I mean this JSON. It looks even more complex than just SQL, let's say. What are the benefits of using JSON?
Because we did not implement validation engine. We take a ready solution. It's JSON scheme. So it just it's already implemented. We just need to implement JSON. So it saves time. Yeah. It's already a library. It's implemented in different languages in Java, Python.
How do you deploy these JSON rules? So can it be changed on the spot? Because what's always a problem, for example, in code is that, well, code you need to deploy it somewhere, in some cases even compile.
Yeah.
Is JSON, can it be easily edited and updated in the system?
It's managed like a Python code. So in
Okay,
code
so
repository,
it's
you just
like that.
deploy it on S3 and see you have versions in code repository. It's tested.
I have a couple of questions. So overall, the idea of this master data management system is to ingest data, structure it, and feed to some APIs through which the whole company, department, whatever branches may use the same master data, right?
Yeah.
And the idea of your POC was like to get rid of Talend and create a new, simplified maybe a version using just lambdas and some salt and pepper.
We replace Talend. Yeah, absolutely.
Okay, so
Just because of again, it's about money. Talent is
Yeah, I got
new version of Talent exists. It's cloud based. It may be better than Carousel.
Ah,
Maybe I
that
don't know.
that one was the existing one is on premise, right?
Yeah, this-
So
this
you anyway,
solution runs on-
guys, had to move to cloud, and the question was whether to buy a huge cloud new version of Talent or to implement something on your own with just minimal efforts and numbers.
Yeah, absolutely.
Got it. Who would like?
So similar question following with the question asked by
A little
Andre.
louder.
Oh, sorry. Okay, so similar question is asked by Andre about the matching percentage things. So there you are calculating the matching percentage on overall basis, right? In the example which you showed,
Mhm.
there were 3 columns, and you were calculating the matching percentage and confidence level on overall basis on all of them together, right?
Right.
So what if, let's say, what if we have, for example, 4 columns? Let's say I'm adding one more column, like say an address column in the same example, the total example, right? And I want to set the precedence of address matching. I mean matching percentage of address to address column lesser than lesser than the other 3 columns, right? Because it's quite possible uh, in the address field when there is when there are more characters, so people may write uh, we can have the set of data with having the same address, but someone is writing postal code before, maybe someone writing at the end, right? But uh, the the other columns have uh, like hotel name and city, right? These are simple straight words. So what if we want to set a precedence of matching percentage on column level? How would we implement that?
Yeah, understand. First of all, this POC is based on specification for this particular POC. And, the formula for similarity was provided by business analysis. It's just sum of similarity with some particular weights for particular properties, right? So in real life, we have much more complex algorithm, right? And it's not the single formula. It's a set of formulas which are applied step by step. So first of all, we calculate similarity based on the one approach, then second. So in our case, we can implement the set of JSON files or set of different sections the same JSON file and run this similarity algorithm in loop. Right? So, and you can apply this, you can calculate the similarity with different formulas on the same data in a loop, and then take the maximum maybe, right? So we just need to repeat the same process, the same configuration, right? But it's still configurable.
Okay, and in our chat, Vladimir said nice presentation and asked what out of the box MDM solutions can you recommend, why, or better to avoid?
Actually, I did not. My personal responsibilities was implementing this custom solution. So I did not investigate the market, right? And the solution which are presented in the market are really. First of all, a lot of functionality, a lot of capabilities in each of them, and sometimes the capability you need, the feature you need, is implemented and works better in one solution, and other solution provides other functionality which is better in that solution. So it depends on on your needs, right? So what you need first. Sometimes you probably just need to set up data catalog and integrate with your current solution. Like, for example, you can install Calibra, integrate it with the solution, and you will have the really good data lineage, really good data catalog, metadata, etc. And without changing your solution at all. So you just can install the software, new software beside of your solution. So it really depends on your needs.
Okay, thank you.
By the way, various guys.
Just a small addition to what you were saying. We have other examples of major clients, without naming, of course, them, who built similar, their own like custom master data management systems. There are tons of approaches, but overall, it seems like, well, a lot of companies don't like what's out of the box on the market and whatever, and go for approach similar to Alexis in conceptual way, well, of course, with different implementation details.
Yeah, and please don't forget that if you, even you buy a solution in the market, you still need to implement some code or implement these pipelines like Intel and SAP. So you still need developers to support. It's not ready for usage right now.
All right. Anybody else with questions?
One more question.
Thank you. Alexei, do you think you can use those solutions maybe in the future as accelerator for other customers? Or flexible?
Take the idea, use the solution. It's for free this year.
Okay, great. Any more questions from the audience? Online? No more? Okay, Alexei, thank you so much for this insightful presentation.
Yeah, thank you.
Yeah, and to wrap it up, I would like to say a huge thank you for all our participants, for our Spain Data community leads, contributors, for making this event and this meetup real. And after this meetup, you will receive a feedback form, and I would like to ask you to fill in this feedback form. It will help us to develop our community and make it really resourceful and nice. Thank you so much for coming. See you soon.